Welcome back guys. So in this video lecture we will finish up putting Hamming code in socket programming. So now the skeleton of socket programming is already there. If you don't know from where the hell this skeleton has come, then I recommend you to watch my previous videos, learn socket programming, and then come here. Okay, so what we will be doing is we'll be sending data bits by encoding from server to client, and on the client side the client would check whether the data it received is right or wrong, and depending on that, if the data is wrong, it will correct it. So let's take an array of data to store in our data bits in here, and let's write down a printf statement so that the user knows what he has to do. So we will write over here, please input 4 bits of data, and now take the data into array at right positions by using the scanf, and data of 0. Now I'm copy pasting this line for the next 3 entries which the user is going to give us, and in this position we would have to write array of index 1, index 2, and understand that we cannot write index 3 because here in the figure which is on the right side, the index 3 is reserved for the parity bit P4. So we would have to take our data in index number 4. So here we are skipping 3 and taking the data in index 4. So now that we have already taken the data in our array at right positions, we need to find out the encoding. So let me comment this first, calculation of even parity for encoding. Okay, now first of all, let's take the 6th position of array, which is the first position in our Hamming code algorithm. So for getting what the first position would be, so the first position is data of 6. We are using our array format. So please note that both of them are in opposite directions. So you need to be really careful while writing down the array indices. So for data 6, we have to XOR 3, 5, and 7th position from Hamming code, which happens to be 4th, 2nd, and 0th position of our array indices. So let's do that. Data of 4 XOR data of 2 XOR data of 0. So this will give us the data of 6, which would be our first parity bit. Our second parity bit is at data at index 5. So that we get by the Hamming code format by XORing 3, 6, and 7, which in our array indices is at index 4, 1, and 0. So let's XOR that, data of 4, data of 1, and data of 0. Done this. Now for our P4, which is data of 3 in the array indices, we need to XOR data of 3, data of 2, data of 1, and data of 0. So let's do that. Actually, it wouldn't be 3. We are finding out the parity of 3. So here, let's write down data of 0, data of 2, and data of 1. So here we have already encoded our parity bit. Now what we need to do is just send this to the client. And as we are sending 7 bits, we are using the for loop 7 times to send the bits one by one. Now let's write n equal to the write command of socket programming, wherein we are using the new sock fd, comma, data of I, and the size, which is an integer. Now let's check whether our right function is correct or wrong. So if n is less than 0, then printf error while transmitting the data. Okay, so by this three lines, by this for loop, we have pretty much successfully sent our data to the client. Now on the client side, the client should also know what the encoded format is. So let's print that out too. Printf %d data of I. Okay, so this is pretty much what we have to write on the server side. Now the socket is closed by closing new sock fd and closing sock fd. So this was it, guys, for the server side. Now we will take a look at what we have to write on the client side. Now let's write down the code at the client side. So at the client side, we will also have an array which we will give data at receiver side. We'll take an array of 10 itself. So our data would be received in this array, and we would also have one more array which would be test. So I will tell you in a minute why we would require a second array called test. And we would require some variables for detecting in which parity block the error is and for detecting which position the error is. So we have already gone through this in the previous lecture. If you don't know anything of this, please watch that and then come here. Okay, so P1, P2, and P4. So this would be our parity bits. Now let's read the data which we have got from the server. A for loop for gaining 12 datas from the server. Now we have to use the read command from socket programming to read the data from the server side. A socket file descriptor is there as a first variable. Then we would take it data at receive at ith position, and the size which we need to specify is integer. And if this command fails, we need to also have a check for that. Then call the error function we have written priorly to tell that there is an error receiving the encoded data. Okay, and now let's print it bit by bit over here. Fine. So we have now received our data from the server. Now we need to do some processing on it, find out if there is an error or there is not. Now, in the previous lecture, we have discussed that how to find out the error, at which position the error is. Here, as an example, I've taken 1101. We have to find the parity bits, and when this data is sent to the client is going to check by checking in which parity block exactly the error is. And as we have known from our last lecture that error can be found out by this formula, where P is the position, P4 stands for parity block of 4. If it is 1, then we would have 4 into 1 plus 2 into P2 plus 1 into P1. At that position we will have an error, so we need to first find out in which block the error is and then correct the error if there is any. Now, as we are having no noise or no EMI, which is the electromagnetic interference, and most of us are sending the data on the same PC by using the loopback address, the data sent from the server to the client would be obviously all correct. So how do we check it? So we check it by putting the data it received in the test array by tampering one bit ourselves. So whatever we need to check, if we have got 7 bit of data from the server, which is obviously right because there is no noise and nothing can change that data. So what we need to do is, if we say that we change the position at number 2, we need to check whether exactly our algorithm is showing that the data is wrong at number 2 and then change that bit. So we will put the data into an array of test and carry out our inspection on that array. So let's write it down there. Please enter the data to be tested. Okay, so this is it. Now let's put that data into the test array. So now that we have our data into our test array, we can carry out the inspections. Now what we will do is we have to check whether it is even parity in all of the blocks corresponding to P1, P2 and P4. So we would have to, let's copy paste this from the client side code and paste it over here. So now we have to check whether for the first one the parity is corresponding P1. So we'll write it P1 equal to data, and then we need to XOR this. So let's replace that with XOR. The second line corresponds to parity equal to P2. So we will write P2 equal to XOR of all this. And for the third line, it corresponds to P4. And P4 will be XOR of everything this. If you're finding it difficult, so why we are using those arrays, again, you can have a look at on the right side and figure out for yourselves how the array indices are there for various different blocks. For P1 1357, for P2 it is 2367, for P4 it is 4567. So here we have found out whether there is an error or not in a particular block, and now we are going to use this formula to find out at exactly which position the error is. So let's write down 4 into P4 plus 2 into P2 plus P1. And I think for better understanding, let's put this into brackets so we exactly know where the error is. Now that we have found out our error, we need to correct it. For that, we would have to write an if else block. So let's write down one. Where the hell is my cursor? Okay, Come on. Okay, found out. Finally found out where the hell was my cursor. It's here now. So if p equal 0, then there is no error in our Hamming code. So if that p is equal to 0, then we would tell the user no error. And if p is not equal to 0, then we have to correct that error at which position it is. So we will write an else over here. So first of all, we would tell the user where the error actually is. So let's print that the error is at position %d, and our %d is p. So we need to tell the user where exactly the error is. Now let's print the data which we have in our test array for our understanding. Actually, what we can do is write down this whole block before we start our if else. Okay, so let's copy paste this and write down this before we start our if else. So we already know what the data is, and if there is error or not, then we will enter into if else. Now we also need to tell the user what the correct data is. We have to correct it when we find out where exactly at which position the data is wrong. So let's write it down over here. The correct data is, now to correct the data we have to flip the bit wherever it is wrong. So if test of 7 minus p, which is the position of the array index, we where we need to flip the bit. So if it is 0, then it is pretty obvious. We will write down test of 7 minus p equal to 1, and else over here. So if it is 1, we need it to be 0. So else we'll take our condition of the error bit being 1, so we will replace that with 0. And now then just print our data with the for loop. %t test of I. So this is the correct data which the client has decoded and found out the error detection by using the Hamming code. Now let's compile this code. So I've compiled the server, so there is no problem in the server. Well, there are quite a few problems in our client code, so let's fix that. So yeah, again, copy pasting things has really taken us into trouble. So first of all, we need to remove this semicolon which we have written against for, and Here, as we have copy pasted from the server side, it has increased our efforts. So let's replace all the data with test. Okay, so now we have replaced all the data words by our test array, and one more error which we have committed over here is that we have forgotten a semicolon over here. So now I hopefully think the client code is right. So now let's save this and again check for compilation. Okay, so we have compiled it again and there are no errors this time. So let's run our program. But before that, let's find out what our output should be by writing and finding out, working out our example. So now let's take our example as data bits 1101. So I've already found out the parity bits for you. So P4 would be 0, P2 would be 1, and P1 would be 0. So the data which would be encoded and received at the client side would be 1100110. Now we have started our program and now let's please input 4 bits of data, says the server. So our data bits are 1101. Let's input that 1, 1, 0, and 1. So the data sent is 1100110, which is exactly the data which we had predicted. Now for testing at the client side, we need to tamper one bit. So let's tamper the 6th bit from this example. So let's write down 6 as 0. So we would pass the data as in the client side as 1, then instead of 1 at the 6th position or the first position of indices of the array we would pass in 0. So our error is at this position, so remember that. Then we would pass 0, then 0 again, then 1, then 1, and the last one is 0. So now it says the data for testing is 1100110, the incorrect data which we had entered, and it says that the error is at position 6, which is absolutely right, and the correct data is 1100110. So it has flipped the data and we have finally got the correct data. So this was it all guys about Hamming code error detection and correction. Thank you. I hope you enjoyed this. See you again.